Okay, so it's 2:35. We'll get started on time because we'd like to leave as much time as we can for Q&A. You've come to the IoT and Edge working group of Kubernetes, the introductory session. At the end, we'll give links to how to join the group, and this deck has been already uploaded in PDF form to the SCED site, so you should have access to it now. With that said, let me introduce the speakers. This is a 4-speaker panel. We've got the people in the order of the pictures. Cindy, why don't you start by introducing yourself?
Hi, everybody. My name is Cindy Xing. I'm a software architect at Huawei, working on Huawei's public cloud infrastructure. My domain expertise is in the distributed system and cloud infrastructure. I worked at Microsoft over 10 years, delivered many server enterprise products and cloud services. For the past 2 years, my main focus is on container technologies and edge computing. I'm not sure if you heard about KubeEdge. KubeEdge is an open source project I contributed for IoT and Edge workload. So you will hear me more about it. Thank you.
Hey folks, welcome. Thanks for coming. I'm Dejan. I'm an engineer at Red Hat, working on IoT and messaging for the last decade or so. And yeah, looking forward to talk to you more about IoT and Edge during these 2 sessions we have today and tomorrow.
And hi, my name is Preston Holmes. I'm part of the IoT group at Google Cloud Platform. I focus on solutions architecture, so I do a lot of work with customers and partners, as well as our product teams, to kind of figure out how this is all going to get put together end-to-end to solve various sort of IoT solution problems.
And I'm Steve Wong. I'm a software engineer with VMware. I'm in the Cloud Native Apps business unit, and I'm assigned to work on Kubernetes. I've been working on Kubernetes since 2015. Edge and IoT is new to Kubernetes, so I started working on storage in Kubernetes, got a background in enterprise IT, and before that, I was an engineer at the founding stage of an IoT company before they called this stuff IoT, called Wonderware, that is still pretty popular in the world today. What we're going to talk about today is this idea of some emerging use cases for Kubernetes. You know, Kubernetes has been around since 2015 or maybe 14 with the original use case of managing containerized apps running in a data center. But really, if you take a step back and look at it from 20,000 feet, Kubernetes could be viewed as a resource management platform that is API driven, and it accepts descriptions of a desired state and drives controllers and operators that attempt to converge on your declaration of the desired state. What if you could use this as a general purpose thing to do things for similar applications? The benefits might be that you could take advantage of a popular, well-architected API, and as you can tell by going to this conference, the velocity of the Kubernetes project and other CNCF projects is such that you'd potentially be able to take advantage of a tremendous and growing tool chain, things that deliver metrics, monitoring, and a lot more. That said, there are some differences between what Kubernetes has been, the environments it has been used in, and what you'd want to expect out of an Edge or IoT deployment. You know, the differences are that many of these Edge IoT deployments are very resource constrained. You don't have this expansibility like you have in a public cloud where you can pretend that you could scale up to meet peak demands. At some point, if you're going Edge or IoT, there's physical space limitations, maybe money, environmental limitations that are going to put hard limits on this. They're often very different networking requirements, and for the most part, these might be completely unattended or not attended by experienced IT personnel. You also might have to deal with disconnected operation, either because of intermittent network or by design, where you intentionally intend to air gap these kinds of systems. So some of the things we're going to talk about here are these three concepts of there's classes of workloads, edge workloads that can run on Kubernetes today, challenges for existing edge loads that might be mitigated by Kubernetes, and then capabilities that at least today can't easily be serviced by Kubernetes. I'll drive, Preston, while you take over here, and just tell me when you want the slide to advance.
Sure. So really what we have here is this idea that if you could actually just go back one.
Okay.
Yeah. That there's a lot of confusion about where does Kubernetes intersect with the requirements of the edge. And so part of what we're doing in this working group is sort of exploring how different features or requirements of edge workloads partition out into each of these three areas. Because I think there can be confusion about whether or not a given capability that needs to be met should be met by Kubernetes or should be met by something that will run on top of Kubernetes. So that's some way of how we have divided up these three areas. And then when we look at where these environments run, the thing we haven't yet covered is really like there's a set of imperatives about why people want to run on the edge, which include things like latency of requirements of workloads that need to run at low latency, privacy requirements, bandwidth limitations. These are all things that drive people to need to run something on the edge. And what counts as the edge can vary depending on what type of workload they're running. So if you want to go next slide and then Jan.
Yeah, so when you started looking into all this, we figure out and that's like whoever you talk to have different aspect of what edge actually means to them. So we, after a little bit of discussions and talking to different kind of people, realize that generally edge we can put it into two broad categories. So basically, people coming from the IoT use space, define something we call device edge, meaning that you would have nodes, physical nodes or hardware present at like a factory floors or retail solutions. So it will be managed and used by the end user of the whole IoT solution. And then you have a large group of people coming from the telcos, CDN providers, and ISPs who already own a huge infrastructure and point of presence infrastructure close to the end users. And that's something we call infrastructure edge. There's a big difference between these two, and there's a difference between the use cases that are intended for these two types of the edges. Because, for example, infrastructure edge usually have like a really reliable network and have a more resources, where in the device edge area you usually see these constraints that Steve was mentioning. So more like smaller resources and more bandwidth constraint in terms of network connectivity with the cloud.
So Dejan, maybe you want to have an audience poll at this point,
Sure.
just to establish who came here for which. Or
So yeah, part of this session is to engage you and try to gather more information about this. So can you raise hands if you're more interested into like an infrastructure edge? Okay. And what about device edge?
So I'd say, looking at this crowd, maybe there's 20% that was infrastructure edge, and 2 to 3x that for the device edge.
And what about people who say there's something else that we're not counting?
Yeah.
Raise your hand if you think there's another block we missed in this.
And I see 2 hands.
Yeah.
Oh, 3.
Awesome, thank you. So what I would ask for clarification on is the device edge actually several different edges? And what I mean by that is the actual end sensors might serve as something that could run Kubernetes or be on top of Kubernetes, or that third category, or it might actually be the gateways, right? And
Yeah.
I view those requirements as being really, really different between like what you would put on a gateway versus what would be on like end nodes. So like in my application, I'm working with cameras, where I actually treat the cameras as the nodes, and I don't have a discrete gateway or on-prem server. So that would be one distinction that I would say.
Okay, we're not here to give you an answer that the definitive declaration is device is one versus the other of your two categories. We're more here trying to explore whether Kubernetes is good for that use case today, or if not, what we could do to make it suitable.
Can I say something? Someone was saying the definition of edge computing is anything other than cloud computing. Okay? So as you can see from this chart, there are all kinds of potential solutions. So as our group was formed back in this August, it's not very long. So while all of us are asking all the questions to ourselves, we like to engage all of you and ask us similar questions, and then we can have the conversation and come to something which is meaningful and beneficial for all of us.
So that said, we'll turn it back over to Preston for our first panel discussion and audience involvement.
And this is where, just to be clear, the four of us are representing a working group that is larger than the four of us. So we've been meeting every other week, a number of folks from a bunch of different companies. And one of the things that we have agreed we want to understand is what are people actually trying to get done on the edge? Because, like to your point, when we thought of these blocks, we are trying as a Kubernetes working group trying to constrain ourselves to just where Kubernetes applies. That doesn't mean there aren't, in this sort of fog sense, many other device types out on the edge as well, right? So in that regard, I don't know if anyone has a quick example, especially I think if you think there's one that you think is a little bit out of the norm or a little bit on the sort of less obvious, but maybe I'll grab a mic and somebody's hand up.
Hi. So we run a municipal government platform, and we provide a kiosk network for people to make cash payments, check payments, credit card payments. So they're touch screens running over a Cradlepoint cell service. And currently, each one is its own Kubernetes cluster, much like inspired by Chick-fil-A, actually. With a nanny service connecting back over to the VPN to an internal ALB to talk to services internally into prod cluster or something like that. So they're very, very small devices, single computer, running a few things of hardware, mostly wired hardware, and a touchscreen. So a couple pods running Chrome, device manager, nanny service, Prometheus, different monitoring systems. So.
Great. So very small clusters on the edge.
Extremely small clusters.
Right.
Yeah.
Maybe we should mention here.
I would like that to be a physical node that I could annotate, and from the cluster have it send, right, manage that as an individual node, have groups of nodes for different use cases.
Right. So the idea of remotely managed nodes in a wide area cluster.
Right, and tag them using pod annotations or something
Yeah.
like that.
Okay,
Maybe we just should mention that some things, and we will cover that in more details in the deep dive session tomorrow, is what kind of workloads we identify so far that people are mostly interested in. So first thing is latency, trying to put more compute resources as close to the data sources in order to be able to react more quickly to the input and provide feedback quicker. Then there's a data ingestion and pre-processing kind of workloads that we think it's important for the resource network environments and helping people to ingest data from the heterogeneous number of sensors and things like that. Then there's a privacy kind of thing where you really want to keep things local and don't want to share it to the global cloud. So, and basically that's where we are at the moment. I think also compute offload is important as well, and try to distribute that, but it's related to basically covering the latency use case more. So
A few others I'd throw out there that have been talked about in the meetings of our groups are what used to be called robo or remote office, branch office. So retail stores, things that might be fully capable of running Dockerized workloads already, but sent out to locations that are very small. The other one would be kind of an inverted cloud provider where there might be outfits like telcos that have cell towers and switching offices that could be turned into data centers at the edge, maybe even hosting multi-tenant workloads. But anybody else got ideas?
This guy raised his hand.
You mentioned some reasons why the workloads are out on the edge, and another one of those that should be considered is lack of connectivity. It's either you're in environments where there's not good infrastructure. We work with a lot of customers in economies which don't have really consistent infrastructure throughout the country. So the edge is the most reliable place for them to do computing. So.
It's actually not released. I just forgot to mention it. So.
Yeah.
Thank you. Okay.
No, and it's one of the ones. So one of the outputs of this group has been a still in progress white paper, right, where we're trying to sort of consolidate and normalize some of these. And I think that's one which is really starting to see some convergence, as poorly defined as edge is in some ways. I think there's been some increasing convergence. I guess I'll call out again to see, for those of you that have thought about the edge and think there's something that you've come across that you have seen infrequently or uncommon in the general discussions of edge. I think it's always interesting to hear if there's sort of an edge case, right? No pun intended. I literally did not realize how bad a pun it was until it came out of my mouth. But I think those are as you're sort of trying to iterate on definitions, continuously overlaying different experiences and different things where you start to see commonalities is interesting, but making sure we're seeing the totality of the boundary.
And if we missed your use case as moderator, I'm going to have to push this along so that we get through all the questions we had. So Cindy, maybe you can address why and how you see Kubernetes as a good fit for these edge scenarios.
Maybe we can talk offline. Okay. I think, so now we talk about the potential workload, why you want to do the edge. So then next question would be, how can we enable it, right? So then Kubernetes can be a solution. Here, before I drill down how we think about Kubernetes can be a potential solution, I'd like to understand how you're thinking. In your current edge scenario, are you using something special, different from Kubernetes, and how you think about it?
Maybe come up just because I know this speaker will feed back.
And by the way, other people can jump in. If you already jumped on Kubernetes and are having a good experience putting it on the edge as it is now, we'd like to hear that too.
Okay, so I'll address your question, briefly introduce myself. I work at Cisco. I'm a product manager for IoT Edge computing, actually. And to answer your question, are we using something else? So over the past 2 years, we have actually built container orchestration that are used in IoT Edge scenarios, and there's production deployed. And part of the reason was, the use cases that were coming for us was like connectivity is a huge. Like for example, in utility use cases, the connectivity of these edge devices is less than 1 megabit per second mesh network, right? So the edge orchestration has to be super lightweight, super optimized for these things, right? Why am I interested in Kubernetes? It's not that our stuff doesn't work. It works great for the use case that we have seen. There's a different trend that is happening, is so-called IT-OT convergence. What it means is Cisco does have huge number of IT customers, and enterprise IT guys, they also have OT operations. For example, a motor company, IT department, are now saying, okay, we have these factories, and we are talking with our OT folks, OT colleagues, and they would like us to manage the infrastructure and policies related to this workloads, right? And IT guys are already using Kubernetes, right? And they would like to continue to use Kubernetes instead of a custom proprietary tool, if you will. Right?
So you see a driving influence from IT and Kubernetes to bring this to
correct,
OT.
correct. For me, it's always the customer wherever they're headed, and that's one
and
of the
I think
reasons.
that something also came up in the conversations we had earlier today, that like this is all driven by trying to focus more on the developers. And so far, all the edge solutions were coming from the infrastructure side, and this is the effort. Like you can see that Kubernetes is winning the game for developers to create their workloads. So you know, in that sense, it makes sense to try to provide them the same tools and the same infrastructure they used to create workloads, and just try to put those workloads on closer to the edge. Yeah.
Okay, let's move on to the next question. What are some of the key challenges for deploying Kubernetes to edge today? I'll throw one out there, and that's the idea that when you run at edge, you're still running on some piece of hardware that isn't maintained by some third party like in a public cloud. And you have issues like updating the firmware on this. Maybe some of these edge deployments aren't even on hardware that is running Linux with a Docker container runtime, and you've even got a challenge of deploying your apps down there. Now, one of the ways, this is a challenge today, but I'm going to throw out an idea that on Kubernetes today, when you deliver your app workloads to your worker nodes, it's done through a container image repository, which could be viewed as just a blob store, but you want it with governance. So you typically have signing, security scanning. But what if that repository could be just an object store that could deliver these, including blobs that happen to be firmware updates? So it's a challenge today, but maybe there's the seeds of a solution. Anybody else has got problems today, has tried to use Kubernetes and run into roadblocks that?
Well, I can speak for the over-the-air update kind of component for the firmware. There are solutions out there, and so my company deploys one, and it does use like a repository-based solution like Git, but for file systems called OSTree. Maybe some of you know OSTree in other contexts. But that's kind of one way to handle that problem you described. And then we also use containers on the edge. But I think Kubernetes does bring some additional complexity, which is non-trivial. Of course, there are ways to manage the complexity. But for our customers, I think that's where one of the biggest challenges is handling that complexity. And right now we use things like Docker Compose, which is sort of a lighter level of complexity to handle some of the configuration management of the containerized workloads. But I think that's how we see it currently.
Okay, anybody else out there who's maybe more closer to the end user rather than vendor? Even if you're not using it today, but you're worried about future problems, speak up.
Yeah, our biggest challenge really has been Kubernetes on bare metal and getting the cluster stood up, this cluster to provision itself as 3 masters, get that all working. If we had a solution, a hardware solution, and a vendor that could go out there, put 3 nodes in each one of our restaurants, maintain it, and know that we have a Kubernetes cluster up, that would be something that would be attractive to us. So you hit that right on the head in terms of the biggest problem that we've had is really Kubernetes on bare metal.
Just curious, are you looking for a vendor to even deliver them for you? I mean,
Sure.
So it would be an as-a-service, just like it was a public cloud, but they send a delivery truck there?
Right.
Or would you think you'd have people who could open the FedEx box and plug it in?
No, as of right now, we have a vendor going out and just delivering our NUCs that we've already imaged and doing it as it is. And it's pretty simple to bring them up because we've done a lot of work to get them to self-organize on our network. But definitely having a vendor or some service that could deliver edge compute and just give us a standing Kubernetes cluster and here's the bootstrap container you run and we'll take it from there.
Right, thanks. One other that brings to mind that I'll throw out there, it's the opposite of what he suggested of getting a vendor to deliver. And that is one thing you really have to concern is this threat model, where when you're out there at thousands or tens of thousands of unattended locations, sooner or later, somebody's going to physically steal one of these things. And if you haven't thought about your threat model and you've got keys to your organization and somebody just goes and grabs a computer, you might have a problem. I don't have a good solution to it now, but think about it. I think we've got.
Yeah, so that is also our biggest problem, that the certificate rotation on the edges. How do we manage that, that we can trust that when we rotate the certificates and we upload those to our cloud where we store those, how can we ensure that that is a secure edge and not the stolen one?
Right.
Mm-hmm.
So trust on the edge is really our biggest concern.
So let's move on, Dejan. Maybe you can share some details of the goals of this working group and.
Maybe we can put also the last slide.
Okay, got it.
Because here we have all the information about the working group, as we mentioned already. So it's really early stage. So we've been operating for like a couple of months now, and when we started, the idea was like, okay, what everybody thinks about the edge. So that's why we started with this white paper effort, just to basically put a blank sheet in front of everybody and try to figure out things like what we talked today. What are the workloads? What are the types of the edges people are interested in? What are the challenges? And try to basically see what we have there. So we have a lot of things already, in a basic form of shape. I think it's good. I don't know when it will be published. It depends.
Well, at least the working document is published now, right?
Yeah.
Well, it's as a doc, yeah. And I think one of the things we're trying to do is make sure we're not completely rehashing all aspects of everything edge. We really are trying to be a Kubernetes working group. So we like to try to constrain ourselves to think about what is at that intersection of Kubernetes and edge. And we also are a working group and not a SIG in that we are looking at what are some of these edge kind of considerations that might apply to other SIGs. So this idea of bare metal bootstrapping might best be addressed by the lifecycle SIG. But do they need to know more clarity about what these edge environments specifically require of lifecycle, for example?
And so, there are a couple of goals that we set up for this working group. And that's first and foremost, like educating us and the whole community about IoT and Edge and where Kubernetes can fit. Then, create some of the blueprints and best practices with the features that we know that we can use today to help people doing Kubernetes on the edge, as some people are already doing, trying to find out the gaps into the feature set and see if through appropriate SIGs we can address those challenges, and then also trying to figure out what things won't be done and addressed by the Kubernetes, and maybe start the new projects and something like KubeEdge that will try to solve some of the things that we don't see that Kubernetes should be including by default to deal with these kind of problems. So these are the things that we have we try to build a community of people who are interested into these problems and try to do and fill these goals going forward.
Yeah, Edge is a buzzword nowadays, and AI, machine learning. So for our group, those are the questions we are thinking of. I think all of us, the beauty for the open source community is it's encouraging open discussions. And then so you all can join us to the work group and contribute. So tomorrow we are going to have a deep dive session. We're going to explain where we are in a deeper level. And then welcome all of you to go there as well.
And then the other thing at our working group sessions that I'd invite would be demonstrations of people who have taken the first step down this journey. We don't really want this to be a forum for commercial sales pitches, so honestly, I'd favor open source solutions and things like that, but...
or customer case studies,
Yeah.
And talk about technical challenges, yeah.
And it's really in an experimental phase. So I think one of the things that we've discussed in the working group is that we potentially need to come up with a whole set of very quick experiments about where Kubernetes applies and where it doesn't, and try some of these things out. So helping connect people on that is important.
So as I mentioned, there's a bi-weekly meeting on Fridays, and you can find in the agenda doc, agenda for the last meetings. In the last couple of months, maybe weeks, we already have a couple of use cases presented from different companies and research groups that deals with it. So there's also already a bunch of material there of talking about different kind of challenges that people are thinking about solving and how they approach these challenges today. Hopefully, we will streamline all these efforts and try to provide best practices for features that are already there in Kubernetes to deal with this.
And if you just found out about this group today, go look at the notes, because we've been keeping notes so you can catch up. If you've got something you'd like to talk about, once you join the group, you're free to suggest items on the agenda. So go ahead and look, just by yourself, you're free to go add an item on the agenda for the next meeting. We are time limited, so we can't guarantee we'll get to it, but we're going to try. Anybody got any wrap-up questions here? I think we're nearing the end of our time slot, but we have perhaps time. There's one.
Hi, guys. I guess my question is, what would be the connection between this working group and the multi-cluster working group? Do you see this working group feeding requirements to the multi-cluster SIG? Just because it seems like a lot of edge problems are problems of scale in many clusters. So is it that this group provides requirements and that group provides solutions? Do you view this group actually producing any code or projects, or is it more of a feeder or a user group to feed the
I'd almost
others?
go so far as to say it's orthogonal to the idea of multi-cluster. You're right that Kubernetes currently has a limit, I believe, of 5,000 nodes. And at Edge, you could have way more than that. And one solution would be to go to multi-clusters. But I don't think we're going to be discussing multi-cluster a whole lot in this group. I think, once you hit the limit, that idea of going to multi-clusters is fairly obvious and probably best addressed in the multi-cluster group.
But no, there's definitely the opportunity to feed into SIGs, right? So to help clarify why a feature or thing might be important and to crystallize it with sort of a demonstration case. It's not to be redundant with the SIGs, but to sort of interact with both lifecycle, networking, multi-cluster. There's a whole bunch of SIGs that could potentially...
Just to add, that's exactly why this was formed as a working group and not a SIG. It's just because it spans multiple SIGs and can work with them.
So is that actually a popular opinion in the room, that we're not creating a cluster per edge location, but we're actually combining all these edge nodes into one massive cluster? That seems crazy to me. That
we're
seems
not
insane.
declaring that you have to do it one way or the other, but I think that I've heard of people who have multiple edge locations in the same cluster.
I was curious if there's been any conversations between this working group and the EdgeX Foundry project, which is a container-based edge project. I think they're currently based in Docker Compose.
I've noticed people from that group who have joined meetings.
No, there's somebody from the Linux Foundation who attends pretty regularly and who's explicitly sort of offered to kind of liaise and have EdgeX participate. There's also some other initiatives in the Linux Foundation to try to tie together some of their multiple edge-related initiatives into sort of an Uber initiative. But so yes, I think there's the same way there's opportunity for interactions with other Kubernetes SIGs, there's opportunities to interact with other projects in open source in general.
Yeah, I think at the last meeting there was an idea to create an umbrella
within the Linux Foundation.
Within the Linux Foundation for all the edge-related projects. So this working group was also called to participate there.
These two, and then that's probably...
Yeah, I think we'll go with these two and then
Can I go ahead?
to call quits.
So I have something I want to add. I experienced myself is the spec that Kubernetes put for its scalability and limits. Like, for example, he couldn't manage more than 5,000 nodes by Kubernetes, but I'm working more in deploying Kubernetes in parameter environment. And with trying to have 5,000 nodes to be managed by one cluster in Edge, it's something not applicable. Like to have 5,000 nodes in one place managed, it's not really physical node. It's not really something applicable. And also having like just 100 baud per node, it was really kind of limits our hardware. So having this kind of only 100 baud whenever CPU cores you have or memory is not really something that you need to reevaluate again. So one example, we start to make the default managed number of bauds in per node up to 255. And we limited that because the single host, IB subnet per node is 255, so you cannot scale more. So I mean, this kind of spec that Kubernetes have for now that match public cloud spec, it might need to be reevaluated when we go to the edge because
certainly going with the typical Kubernetes defaults, in my experience, is a bad idea. You have to override some of those.
So I'm just trying to make sure I'm in the right spot. But so our use case is really about highly resource constrained nodes, and I mean, to me, that's an application of Edge, and I just want to make sure that is something that's the subject matter of this, because everything else sounds like it's a much larger scale, but. We're fighting things on the other end where we're having to throw things out to get it down to scale to the nodes we have.
And that's why there's still this sort of open point of discussion about whether or not managing nodes in a large WAN cluster is still viable or not, right? So I think for certain use cases it may seem crazy, but there are cases where simply managing to run even large sections of the Kubernetes control plane on that edge is not possible, and that's where things like virtual kubelet are interesting, et cetera. So I think these are far from resolved, right? That's why we have these discussions, because it is a sort of a frontier within a frontier.
Okay, I think we're going to have to wrap it up, but I'm not sure, we might cancel the last meeting because of holidays, but
start the new year with joining a new working group.
Yeah. And by the way, we have this deep dive session coming up tomorrow. So if you liked what you heard here.
And the goal is to get a bit more meaty into some of the specifics tomorrow.
But thanks for coming.
Thanks for coming.
Thanks.